Hi, grade 10s. Today we are going to take the idea of functions and take it one step further. Today we are going to take a look at how to represent functions in many different ways. One of the wonderful things about mathematics is connections. Connections between what you have learned. There's some things that you learn in math that are completely separate from other things. Completely separate, and there'll never be connections between. But where math really gets pretty cool to me is where you start seeing where things are related and where things are linked, and the patterns that you see or the different ways to represent something help make math be one of the most interesting disciplines I've ever seen. So today we're looking at how to represent functions in many ways. We talked about functions during the last class, and we are going to look at the relation 1, 1, 2, 4, 3, 9 as follows. We can express that in a variety of different ways. So what are some of those ways that we can do that? Well, let's bring out the special pen here. We'll start by looking at that as a table of values. And here's our table of values right here. We can write those three ordered pairs in a table. And there's our table of values. Okay. That's one way of looking at that. Now that tells us one thing, but it doesn't necessarily tell us everything. Okay. We can take a look at a mapping diagram, and the mapping diagram kind of has the same information as the table. It has each of the inputs and it tells where it goes. Very similar to the table of values. Okay. The other three are a little bit different, but if you started with any of these 5 representations, you should be able to switch between them and come up with a way of the figuring out the other 4. So here's a graph, and that graph will have the points 1, 1. It'll have the point 2, 4, and it'll have the point 3, 9, but it has a whole lot of other points here as well. And you see that if you join those points, you get a nice curve, okay? And we also have some words. Square the input. If you take each of the numbers that are in the input and you square them, you get the y values. And if we go back to the table of values here for a second, 1 squared is 1, 2 squared is 4, and 3 squared is 9. And if we look at the equation is going to follow very closely with the words. Y equals x squared. Okay? Y equals x squared. And again, that's just a different way of expressing this relation. There's 5 ways of representing this function. And again, the whole idea is if you're given one of those ways, then you can come up with the other ways. So that's the whole idea of today. Now, here's an example. For each mapping diagram, give the rule and write out a table of values. Okay, so 1, 3, 2, 6, 3, 9, and 4, 12. Now, I'm not here with you today, but I'm guessing that you have the idea of what this pattern is. Okay, you see what you have to do to the input to get the output, and that's the whole thing. What do we have to do with the input to get the output? Well, if we take the input and like I said, I know that some of you see this. Give the rule and write out a table of values. So now what would our table of values be? Well, we can say input and output, and it would be 1, 3, 2, 6, 3, 9, and 4, 12. Okay, there's our table of values. Okay, this one's always a pretty straightforward one. Okay, this next one really throws people for a loop. Can you figure out what you got to do with the input to get the output? What do you have to do with the input to get the output? The hint I'm going to give you is this. You're going to do something to the input, but you might need to incorporate a different number as well. So what do you need to do with the input to get the output? The last question, you just multiplied by 3 and you got every number in the output. But here, it's not so easy. It's not so easy. But when I tell you what it is, you're going to know it. You're going to see it. And you're going to wish you could have come up with it. But I'm hoping that in my stalling, that one or two of you have figured it out. So let me do the big reveal here. Ten minus the input is the output. So the output is the input subtracted from 10. Okay, so the output is the input subtracted from 10. Very simple. Okay, and again, if you didn't get it before I put it out there, I know you're gonna see it now and be like, oh yeah, I know what you're talking about. So 1, 9, 2, 8, 3, 7, 4, 6. Okay. One quick example. Then it's some time for some homework here. Given the table below, describe the function in words. 1 hour, pay of $12. 2 hours, pay of $24. 3 hours, pay of $36. 4 hours, pay of $48. How would we describe the function in words? Well, how would we describe the function in words? Well, the pay is 12 times the hours, right? Because every hour gives you $12. Easy enough. And if we can describe a function in words, then we can describe it as an equation. Okay? If we can describe it in words, then we can figure it out as an equation. Because really we're just taking the words and writing it as an equation. So pay, we can use the letter P. The word is can be represented by an equal sign. 12 can be represented by itself in numeric form. Times is multiplied. And the number of hours, well, we can let H be the number of hours, or we can use T. Either way, that's fine. So I want you to work on pages 132 to 134, numbers 1 to 5.